We have successfully completed the solar light concentration, and now it's time to start working on the solar tracking. Watch each and every step. We will discuss the circuit diagram, then we will be doing the soldering, and then at the end we will assemble the whole project and test it. So let's get started. So friends, as you can see, this is the complete project schematic, not including the Arduino section because we will be making our own ATmega 328 microcontroller board. So first of all, we discuss the light sensing circuits and the edge bridge. So let's start with the edge bridge. We will be using two relays for controlling the direction of the motor. So as you can see over here, this relay will be controlled with the help of this transistor, and we are using 2N2222 NPN transistor. If you want to learn how we design a driver circuit for a relay, so watch my tutorial on relay driver circuit design calculations. And this is a 10K resistor which is connected with the base of the NPN transistor, and this will be connected with pin 8 of the Arduino, and similarly this one will be connected with pin 7 of the Arduino. So as you can see, the collector side is connected with one side of the relay coil, and the other side of the relay coil is connected with 12 volts, and similarly over here. And as you can see, the motor is connected with the common pins of the relays, and the normally closed wires are connected with plus volts of the battery, and the negative terminal of the battery is connected with the normally open pins or contacts of the relay. And now let's discuss this one. So this circuit will be used for the light sensing, and we are using LGR for the light sensing. As you can see, the LGR is connected in series with a 10K resistor which makes a voltage divider. So on one side we have connected the ground, and on the other side the 12 volt is connected. So when there is no light falling on the LGR, it will offer maximum resistance, so the voltage will be equally divided. This is also 10K and this is also 10K, so the voltage will be equally divided, so we will get 6 volts over here. And on the non-inverting side we are connecting this with the variable resistor output. So the variable resistor is connected with 470 and 472 resistors. If you want, you can also use 330 ohm resistors. I will be using 330 ohm resistors because I'm not having these 470. And this is a 12 volt. We are connecting a 12 volt with the IC. This is a 741 op-amp which will be used as a voltage comparator. So we will be comparing the voltage which is coming from here with the reference voltage, and this way we can find that whether the light is falling on the LGR or not. This is a 10K resistor which is connected in series with the 1K, and from the middle we are taking the output, the divided voltage, and we are connecting this at the base of the 2N22 transistor. We are connecting these two resistors because the output of this IC is approximately equal to the input supply voltage, which can damage the base of the 2N22 transistor. So that's why we divided voltage and we gave a voltage which is below 6 volt, because if we give a voltage which is greater than 6 volt, it can damage this transistor. And the rest of the circuit is exactly the same as over here. So this is a 2N22 transistor, a relay, and the other side is connected with 12 volts, and the common of the relay is connected with a ground, and then we will take in a wire from the normally open and we'll connect it with pin 2 of the Arduino. So these are exactly the same circuits, and the output of this circuit will be connected with pin 4 of the Arduino or ATmega 328 board. So first of all, we will make our own ATmega 328 board, and then we will start the soldering. So let's start. This is the ATmega 328 microcontroller pin out, and let's start with the first pin, which is the RST, and RST means which is the reset pin. We will connect a 10K resistor and a push button with pin number 1 so that we can manually reset the microcontroller. Pin number 0 and 1 are the RX and TX pins, which can also be used as digital pin D0 and D1. And pin number 4 is D2, pin number 5, D3, D4, and D5, D6, D7, which are 11, 12, 13. Well, if you can see the pin number 7 and 8, with the pin number 7 we will connect plus 5 volts, and pin number 8 will be connected with the ground. Pin number 9 and 10, we will connect a crystal which is 16 megahertz, and pin number 14 is 8. So as you can see over here, digital input, output, and the analog, digital or output. So these are the analog pins which can be used as analog and digital pins as well. So this is the 14, which is B0, and then 15, 16, 17, 18, and 19. And as you can see, pin number 5 and 6 can also be used as PWM and can also be used as digital input output pins, and similarly the pin number 3 is also PWM. And like you can see over here, 9, 10, 11, 12, and 13. Now pin number 20 is plus 5 volts. It will be connected with the 5 volt, and this one, which is pin number 21, will also be connected with 5 volt, and pin number 22 will be connected with the ground. And pin number 23, 24, 25, 6, 27, and 28 are the analog pins, which are A0, A1, A2, A3, A4, and A5, and these pins can also be used as digital pins. To power up ATmega 328 microcontroller, we will be designing our own 5 volt regulator supply using 7805, which I will show you in the PCB designing. So these are the ATmega 328 microcontroller pins, and using this information, now we will be designing our own PCB. And once the PCB is designed, then we will be doing the soldering, and then at the end we will practically check this. So my friends, this is the PCB I designed in CADsoft Eagle 6.5.0 Lite version. If you want to learn how to design PCBs and how to make PCBs, how to do automatic routing, how to do manual routing, please watch my tutorials on PCB designings and schematic making. So now let's discuss this design. I've already created this. So let's start with the pin number 1 of the ATmega 328 microcontroller, which is the RST, and it is connected with 10k resistor, as you can see. So one side of the 10k resistor is connected with pin number 1 of the ATmega 328 microcontroller, and the other pin is connected with the output of the 7805 voltage regulator. So it means that we are giving 5 volts through 10k resistor to pin number 1. And then a push button is connected. So one pin of the push button is connected with the ground, and the other pin is connected with pin number 1. So when we press this button, it will give ground to the pin number 1, and it will reset the Arduino. So that is the manual reset. And then we start with the RX and the TX, as we know that the microcontroller pin number 2 and 3 are the RX and TX pins, which are used as the serial port. We can also use this for the debugging, and we can also use this for interfacing all those modules which do serial communication. And now the pin number 4 is the digital pin 2, pin number 5 is the digital pin 3, and pin number 6 is the digital pin 4. And now as you can see over here, pin number 7 of the ATmega 328 microcontroller is connected with a 5 volt, and similarly pin number 20 and 21 are also connected with 5 volts. So these are connected with the 5 volt. And pin number 22 is the ground, and it is connected with the ground, as you can see. And pin number 8 of the ATmega 328 microcontroller is also ground. So as you can see, the ground wire is coming from here and connected here. And we know that pin number 9 and 10 has a crystal which is 16 megahertz. So one pin of the 16 megahertz crystal is connected with pin number 9, and the other pin is connected with pin number 10. And 22 picofarad 2 capacitors are connected. So one is connected with one leg, and the other one is connected with the other leg, and the remaining 2 legs are connected with the ground. Pin number 11 is D5, digital pin 5, and pin number 12 is D6, 13 is D7, and 14 is D8. So similarly, 15, 16, 17, 18, and 19 pins of the microcontroller are the digital pins D9, D10, D11, D12, and D3. So some of these digital pins can also be used for the PWM, which I already showed in the pin out of the ATmega 328 microcontroller. And then the microcontroller pins from 23 to 28 are the analog pins, which are A0 to A5, and these analog pins can also be used as the digital pins. So the ATmega 328 microcontroller will be powered by using our own supply, and this supply consists of the 7805 voltage regulator. At the input of the 7805 we are giving the input voltage, the ground is connected with the supply ground, and the output is connected with the ATmega 328 microcontroller to power up this IC. Over here you can see that we have a 330 ohm resistor, an LED which is 2.5 volt LED, and its amps are 20 milliamps. So using the ohms formula V is equal to IR, we can find out the value of the resistor which will be needed to on this LED without burning out. We will also be needing a 10 microfarad capacitor which is connected at the output of the 7805, and if you want you can also connect one capacitor at the input of the 7805, and this is used for the filtering and also works as a reservoir. So once my design was completed, then I copied all the necessary files and sent it to the local PCB making shop, and that did the rest of the work for me. As you can see on the left side, this is exactly the same PCB which I discussed. And now let's start soldering the components, and then we will doing the testing. So my friends, this is the PCB, and let's start with the base socket for the ATmega 328 microcontroller. Let's first install this, and now let's start the soldering. Now make sure that when you do the soldering you don't apply, because too much heat can damage the copper wires and can also damage the base socket because that's made up of plastic. So make sure you don't apply too much heat. So now as we are done with the soldering, now it's time to do the testing. We will check the short circuit, set the DMM on the continuity, and now this is the terminal block, and with the help of this we can connect the supply wires. So we will apply the same strategy over here. We are not supposed to apply too much heat. This is the LM7805 voltage regulator. The leftmost leg is the input, the middle is the ground, and the rightmost is the output. So this is the 5 volt voltage regulator which will be used to power up the microcontroller. And now after soldering, then check the continuity and the short circuit. This is 10 microfarad capacitor which will be used at the output of the 7805. The larger leg is the positive and the smaller one is the ground. And as you can see, this white line on the capacitor, it indicates that this leg is the ground one. So now let's install this at the output of the 7805. So after the soldering is done, and now you can see these three components are installed: the terminal block, the 7805, and a 10 microfarad capacitor. And now it's time to install the 330 ohm resistor and a 2.5 volt LED. So now all these components are installed. Use a cutter to trim the excess wires and make sure you wear the protective glasses. And now it's time to connect the supply wires with the terminal block, and these two wires can be then connected with the 12 volt battery or with an adapter. So over here I'll be using 12 volt adapter, which is 2 ampere, just for checking. So as you can see, the LED is turning on and the voltage regulator is working. Now this is 16 megahertz crystal. And now let's solder this, and we will also connect 22 picofarad capacitors on both sides of the 16 megahertz crystal. So all the components are installed, and now we are ready to use ATmega 328 microcontroller, program that, and then we can use that to control different things. So over here I will be using an LED. So first of all, Use this Arduino Uno to program the ATmega328 microcontroller. Connect this with the laptop through a USB cable. Write an LED blinking program. Upload the program in Microcontroller. And now remove the ATmega328 microcontroller and use it in this circuit. Now over here you can see that I have soldered an LED. The resistor is 330 ohm and one side is connected with pin number 13 of the ATmega328 microcontroller. So now let's connect the supply wires. It's the ground and this is the 12 volt, and now you can see the LED is blinking and our circuit is working. It's just working fine. So my friends, as you can see, I'm done with the etching process. I did the drilling and now it's time to clean the PCB. I used ferric chloride for the etching and now I'm using a sandpaper to clean the PCB. So friends, as you can see, the PCB is now clean and now we will start the installation of components. Now this is the SPD type relay, 12 volt relay. Now we will start a soldering. And make sure you don't apply too much heat. So the relay is soldered. And now it's time to solder the 741 op-amp. Again, don't apply too much heat because it can damage the 741 IC. So it is soldered and now it's time to check the continuity and the short circuit. So there is no short circuit, and also let's check the continuity. Yeah, this okay, fine. This one is also okay. Continuity is okay. This point is also okay, right? And this one is also. This is a 2N2 transistor and there is no short circuit. Go to the access wires. Now you can see the components are soldered. Now these are 330 ohm resistors which will be soldered with the variable resistor. So now the resistors are soldered and now we will need 3 wires for the variable resistor. Apply some solder to the legs of variable resistor, and first also apply solder to the wires so that we can easily solder these wires with a variable resistor. All the 3 wires are soldered. As you can see, the red, green and black. The red will be connected with the 12 volt and the black will be connected with the ground and the green will be connected with the metal. Use silicone to fix this variable resistor on top of the relay, and now we are soldering a 10K resistor which will be used in series with the LGR. Now we will solder 2 wires for the LDR, and this is a Vera board, and now we will solder 2 LDRs on the Vera board, and later we will connect those wires with the LDRs. This is one LDR and we also need another one. So now the LDRs are soldered. Now as you can see, these 2 wires will be connected with the LDR. So no matter which wire you connect with which leg, so 2 wires are soldered. Now it's a 1K resistor, and this is a 10K which will be used in series with the 1K. Now you can see all the components are soldered. Now we'll need two wires, the red and the blue, and these will be used for supplying voltage to the circuit. As you can see, my friends, this is exactly the same circuit. So we just connected all the ground wires and the supply wires, and now we will connect both the boards. So now we are connecting this ground wire for the ATmega328 board, connect a black wire, and this the other end of this wire will be connected with the common of the relay, as we will be giving a zero signal to the microcontroller. So this is the H bridge. These are two relays and two resistors, 10k resistors, and now we will do the soldering. So first of all, we will solder the 10k resistors, and then after that the two relays. You can also watch my tutorials on the H bridge designing. So now these are two transistors. Okay, now we are applying some solder to the wires to increase the current rating of the copper wires. So now we are connecting the yellow wire and the red wire with which we can connect a motor. And now these are the supply wires. The red is a 12-volt wire and the blue is the ground wire. And now these two wires are connected with the 10k resistors, later which will be connected with pin 7 and 8 of the Arduino or ATmega328 microcontroller. So now let's check the short circuit and the continuity. So my friends, this is the program which is written for the solar tracker, and as we are using two circuits for detecting the sunlight, so the LDR1 equals to 2. It means that the output of the one circuit will be connected with pin 2, and the output of this other circuit will be connected with pin 4. The H bridge will be connected with pin 7 and pin 8, so integer right equals to 7 and integer left is equal to 8. So these are for the right and left wires, and then we start with the white setup and white loop. So as you know, my friends, that every Mega and Arduino Uno program has at least two functions, which are the white setup and white loop. White means that this function is not returning any value, and the empty parentheses means that these functions are not taking any arguments as the input. So pin mode LDR input, as we will be using the output of those two circuits as the input. So pin mode LDR2, this is also an input, and serial.begin 9600, I will be using this for the debugging. And pin mode write output, and as we will be controlling an output, as we will be controlling a motor, so as we know that motor is an output device, so that's why the right wire is also output and the left wire is also output. And then the white loop. If digital read LDR equals low and digital read LDR2 equals high, it means that if on this circuit the light is falling and on this circuit the light is not falling, so it means that the motor will be rotating in right direction, and this is high and this is low, then the motor will be rotating in the other direction, and else we keep the motor in off state. So as you can see, so this is a very simple, basic, small program, and that's it. So my friends, as you can see, all the circuits are connected. These two are used for the light detections, and these two are the LDRs connected with these circuits. So one LDR is connected with this circuit and one LDR is connected with this one. And this is the ATmega328 microcontroller board, which I already explained in very detail, and this one is the H bridge, which I also explained. So these two wires are the 12-volt and the ground, and these two wires are connected with pin 7 and 8 of the ATmega328 microcontroller, and the output of these two circuits are connected with pin 2 and 4 of the ATmega328 microcontroller as per the circuit diagram which I explained. So over here I have connected 12 volt over here and over there also. So now let's Now, right now the light is falling on both the LDR, so that's why you can see the motor is stopped. So when I cover one LDR, you can see the motor is rotating in one direction, as you can see. And when I cover this one, so you can see that the motor is rotating now in another direction. And when there is no light falling on the sensors, the motor is stopped. And when there is light falling on both the sensors, still the motor is off. The motor will be in running condition when there will be falling light only on one sensor. So let's, for example, right now light doesn't fall on this one, but light is falling on this one, so that's why the motor is rotating in one direction. So I'm using this motor just for the demonstration purposes. Later on I will replace this motor with a gear motor having a very low RPM and a high torque. So my friends, the model is ready now. It's installed on this base, and over here you can see it has a gear motor. So the interfacing is very simple actually. Over here we have to supply 12 volt, and also over here and over here we have to supply external supply for the DC motor. As you can see, the positive and the ground wire are coming directly from the battery to here, so we will connect external supply, and the red and the yellow wires will be connected with the motor wires. So that's it, very simple. And right now I have installed these two sensors over here on temporary basis, because after this I will have to disassemble this. So these are the two sensors which will be always in front of the sun. Okay, so right now the torch is already on, so let me connect this 12 volt over here. Okay, so as you can see, okay, so let's suppose that my cell phone is the sun. So as the cell phone light is falling on the LDR, so that's why it's just in front of the cell phone. So I'm moving this side, and as you can see it's rotating. So as I'm coming on this side, as you can see the motor is also rotating. So now as it's in front of the light, so it's not moving. And it's really quick response. It's in front. Okay.